Carbohydrates, dietary and functional fiber. Dietary fibers are found naturally in foods. They are non-digestible carbohydrates and lignin, intact and intrinsic in plants. Functional fiber, on the other hand, is isolated, extracted, or manufactured non-digestible carbohydrate with known physiological benefits. This slide reviews the dietary and functional fibers we find in our food or food products. You can see that chitin, chitosan, polydextrose, polyols, psyllium, and resistant dextrins are only functional fibers that have been isolated, manufactured, or extracted. All fibers can be classified as soluble or insoluble, with soluble fibers dissolving in hot water. You can see this breakdown classification of the soluble and insoluble fibers in this diagram, with the soluble fibers consisting of fructans, psyllium, beta-glucans, pectins, gums. Insoluble fibers are lignin and cellulose. Hemicellulose can be classified as both soluble and insoluble. Here are food sources of each type of fiber. These top types, cellulose and lignin, would be the insoluble, pectin, gums, beta-glucans, resistant starches, and fructans being the soluble fibers, with hemicellulose again being classified as both soluble or insoluble. You can see that many whole grains, root vegetables, wheat bran, fruit with edible seeds, broccoli, celery, and nuts contain insoluble fiber. Foods higher in soluble fiber includes oats or oat products, beans and legumes, barley, apple, and potatoes. We will focus this section on select beneficial effects of dietary and functional fibers, classifying the unique benefits of soluble versus insoluble fiber. Much of the fiber that we consume is insoluble fiber from fruit, vegetables, and whole grains, particularly wheat bran. A physiological benefit of insoluble fiber is that it increases fecal bulk. Consuming inadequate insoluble fiber can increase the risk of a condition called diverticular disease, also colon cancer and constipation. Diverticular disease is the infection and inflammation of tiny pockets formed in the intestine. It is important to consume adequate sources of insoluble fiber to promote regular bowel movements and to reduce the risk of diverticular disease, colon cancer, and constipation. Soluble fiber has additional beneficial physiological effects. Due to its ability to bind water and its viscosity, it delays gastric emptying, holding food in the stomach longer. This will increase satiety and may also increase levels of satiety hormones, including glucagon-like peptide 1, or GLP-1, and peptide YY, or PYY. The viscosity of soluble fiber also decreases the rate of nutrient diffusion into the gut, which attenuates or slows the increase in blood glucose after consuming a carbohydrate-containing meal. Other effects of soluble fiber include a reduced mixing of gastrointestinal contents with digestive enzymes, which reduces the activity of those digestive enzymes. This particularly affects the digestion and absorption of lipids and can lead to a lowering of serum lipid levels. Another characteristic of soluble fiber is that it acts as a binder, binding nutrients such as certain minerals, bile acids, and lipids. This can alter mineral absorption, it can increase fecal bile acid excretion, and reduce lipid absorption. Since cholesterol is used to make bile, the increased fecal bile acid excretion leads to a reduction in serum cholesterol levels. The reduced lipid absorption can also lower serum lipid levels. This diagram outlines the effect of soluble fiber as a binder to certain minerals, bile acids, and lipids. Therefore, soluble fiber's water-holding capacity, its viscosity, and its ability to act as a binder contributes to the following beneficial effects, which include an increase in satiety, decreasing lipid absorption and serum lipid levels, increasing fecal bile acid excretion and serum cholesterol, and attenuating the blood glucose response after consuming a carbohydrate-containing meal. Despite these various beneficial effects of soluble and insoluble fiber, many individuals do not consume enough fiber-containing foods. According to a recent report published in the American Journal of Medicine in 2013 by Grooms and colleagues, the NHANES, or National Health and Nutrition Examination Survey, from 1999 to 2010 reported an average fiber intake of 15 to 17 grams of fiber per day among adults aged 20 and older. However, you can see in this table that the adequate intake level for fiber for men, is 38 grams per day, and for women, it's 25 grams per day, which is much higher than what was reported, the 15 to 17 grams per day in the NHANES survey. The adequate intake level averages to approximately 14 grams of fiber to consume per 1,000 calories. There is no tolerable upper intake level for fiber. However, it is generally not recommended to consume more than 50 grams per day.